All right, folks, looks like everybody has come in. I am up against some pretty amazing presentations at Summit this year, so thank you very much for being here. My name is Thomas Cameron. I'm the Chief Architect at Red Hat for Canada and the Central Region of the United States. I manage those territories out of Austin, Texas. Managing Canada out of Austin. So I am a technical resource for our strategic customers, as you can see from the alphabet soup after the name. I know a fair amount about this stuff. I certainly don't claim to know everything, but I hope that I will be able to answer any questions that you have, so don't hesitate to ask them. Today, we are going to be talking about Red Hat Network Power User Tips and Tricks, packaging software. My contact information is up on the screen. I'm very easy to reach. I am Thomas at redhat.com. Been there for a little while, so I was able to knife the guy who originally had that alias. I'm Thomas D. Cameron on Twitter, and the rest of my contact information is up there. I'm on IRC, on Freenode all the time as Choir Boy. Yes, there's an interesting story behind that. Ask me at the pub crawl. I am my homepage is people.redhat.com/tcameron, and this deck will be available, actually is available, at people.redhat.com/tcameron. So I've seen people like taking pictures of the screen. You're welcome to do that if you want, or you can just go download the PDF. Either one's fine. And then my blog is excogitate.us, and you can reach me on Google Talk as Thomas Cameron. Today we are going to be talking about Red Hat Network and Red Hat Network Satellite Server. Talk about a couple of assumptions, and I will talk about packaging internally developed software and packaging commercial off-the-shelf software for which you will not have source code. They're important changes in the way you build RPMs between the two of those. So a little bit about Red Hat and the Red Hat Network Satellite Server. RHN Satellite Server, the best package or the best platform for managing Red Hat products. It's an awesome technology. It's 10 years old, which means, yes, it's long in the tooth, but it also means it's really, really solid and very, very capable. We've got literally hundreds of thousands of servers under management at customers in practically every vertical you can imagine. As Fedora is the upstream open source, very rapidly moving project from which we draw technologies that become Red Hat Enterprise Linux, the Spacewalk project is the upstream open source community, very rapidly moving project from which we draw technologies that become RHN Satellite. And you can take a look at what's coming in Satellite by going to spacewalk.redhat.com. So some assumptions. I assume that you at least are already familiar with, I don't know, what an RPM is. This is something of an intro, but we are going to be moving relatively quickly. If you have any questions, don't hesitate to ask. For packaging internally developed applications, we're going to use an app for which you can get the source code as an example. But this will work across the board no matter what it is if you're using like open source technology and you want to package it up for your environment. Let's say, for whatever reason, you want to get a newer version of Apache than the one that comes from Red Hat Enterprise Linux, and you decide, because you guys have come from a long history of maybe Sun ownership or something like that, we can help you with that problem, by the way, that you're going to put it in opt Apache. Okay, cool. It's not a best practice. It's not what we recommend. In fact, I will tell you several times through here, the best way to do this is just to get packages from us. But if you have something that's not available from us, I'll show you how to do it. So a couple of tips and tricks for getting started in building packages. Make sure that you have the development tools package group installed, so just do yum group install development tools. I also cannot recommend strongly enough that you install the RPM dev package. So yum install RPM dev. First, what we're going to do is talk about how you would normally install open source software. It's usually fairly straightforward, right? You download the tarball, you extract it, you go to the directory, you do configure, make install. Right? I mean, open source package with automake tools and autoconf tools are usually pretty easy to do. But let's say, because, okay, I'm gonna put it into a non-standard directory, so I need to make changes to the way that I build it, and you should never, ever, 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 ever build packages as a root user. Because mistakes get made, right? I am human. I will screw stuff up if given half an opportunity. So don't ever build packages as root, right? Well, what that means is when you do configure, make, install, it's going to go try to install someplace that you don't have access to because you're doing it as a user. Because we never, ever, 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 ever install packages as root or build packages as root. So we're going to do configure prefix equals opt Apache because that's where it's going to be installed. We do make, and then we do make destr equals var temp install. /var/temp space install. So, and this is what that looks like, right? I make the directory var temp build, I go to temp build, I wget my latest and greatest Apache package, I tar zxvf it, I go to that directory, I do configure prefix equals opt Apache, and make install with the des dir equals var temp, right? Easy, piece of cake. I run that command and grumble, 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 grumble. I'm a smart guy, I can do this, right? I can do this. So, every IT administrator's most important tool, Google, right? Eureka, I found it. I figured out that I need to patch the makefile.in, so I edit it, I recompile, I success, I tar it up, and it's ready to go, right? So I VI the file and I fix it. I run configure, prefix equals, make des dir equals, and install. And sure enough, it goes through, it's done, and I tar it up. There's my apache.tgz file. I'm good to go. I log in as root and I extract it out. And then I remember, yeah, you know what? I got to change the path statement, and I probably ought to change the man path statement as well. No problem. I'm going to go edit etc profile because I'm just going to add that in, right? That works. Makes sense. Wait a minute. I got to start and stop this bad boy too, don't I? It's okay. I'm just going to pop a line into etc.rc.drc.local. Piece of cake, all right? So I do it, I unzip it, I put it in opt Apache, I go and I hack my etc profile, and look, hey, I commented it, right? That's good enough. I put it in there. I edited my path statement, my man path statement. And then, of course, rc.local, that's the best way to launch software, right? Hey, I know hupped it. Now your company has a bleeding edge version of Apache. No one but you knows about the patch that you had to make. Job security, right? Life is good. They can't fire me now, damn it. No one knows about the hacks that you did to etc profile, and even if they did, they're going to have to manually apply this to every system upon which you have installed this package. Now let's say you win the lottery or get fired. You're gone. You're never going to darken the door of this place again. How are they going to know what versions are installed on these systems without manually going and checking? How are they going to check the integrity of those installations? They're probably going to need to figure all this stuff out all over again if they need to go to a new rev. The failboat has arrived. So let's look then at how to package internally developed software. Let's figure out a way to make it easier to deploy. Let's make it an easier way to consistency check it, and an easier way to do version control on it. So, to package internally developed software, whether it's something you've downloaded from an open source project or something that somebody has developed internally, there are some steps that you want to take as a non-root user, right? Because we never, ever, ever build packages as a root user. As a non-root user, we run rpm dev setup tree. It will create a directory in your home directory, an RPM build directory, and the directories underneath it, and it'll create an RPM macros file. I have run into some weird issues, tested in your environment, but there's a line in there that does a architecture installation post check for path checks. I've seen some kind of flaky results with that, so you may want to comment that out, test it in your environment. But what that looks like is, I'm logged in as a regular user, right? I'm logged in as the make RPM person. I do an ls, and all I got is just my dot files. I run rpm dev setup tree, and sure enough, I've got my rpm build directory and my rpm macros file, and if I cat that file, you'll see that it sets my home directory, it sets my compiler flags, my SMP flags, and it has that arch install post. We run the check paths command. Again, I've seen some weird issues with that. Test it in your environment. When I do a find against the RPM build directory, it creates my sources directory, my RPMs, my build, my specs, and my SRPMs directories. So it does all that work for you. I love RPM dev. It's a cool utility. I comment out that section, like I said, and I need to take an additional step. You should never, ever deploy packages. In fact, Yum will not allow you to install packages that are not signed. So we use GPG. GPG is, or the GNU Privacy Guard, is a free open source implementation of the PGP technology. Per the man page, it's a tool to provide digital encryption and signing services using the Open PGP standard. For the purposes of this presentation, we're going to use GPG to sign internally developed packages. You should not allow unsigned packages to be installed. Like I said, Yum will not even install them. And your package building / signing account will generate a key pair. Keep that key pair private. Make the public key, keep the private key private, the public key publicly available. I recommend that you have some sort of a secure signing process. You may have anybody or any team of folks who can build RPMs, but you need to control the signature of those RPMs. Once they get out into your satellite environment, once they're signed, they can be installed on anywhere. So make sure that you've put some checks and balances in place. Multi-factor is not a bad thing. One team builds, another team signs and deploys. And the way that we do this is do GPG -- gen key. It's going to ask you several questions, and then you export it. And I'll show you what that looks like. So GPG gen key, it's going to ask you what type of encryption you want to use. In this case, the default is RSA1 and RSA2. That works fine. It's going to ask you how long the key is. The default is 2048 bits. Again, that's fine. If you want to go more secure, you can do that as well. And then you're going to set the expiration date for your GPG key. Generally, my key, I set it to not expire, and it's years old and hadn't been compromised yet. And then it's going to ask you for identifying information. Give it your real name, or in my case, my account name, the email address, and then you're going to say, is this correct? You're going to say, OK. It's going to ask you for your passphrase for your key. You're going to type it in. You're going to type it in a second time to confirm it, make sure it's right. And then it's going to need some entropy. Usually what I'll do is I'll open up another shell and do something like update DB or something. Generates a lot of interrupts because it's got a lot of disk activity. After it gets done, it'll kick out, this is the key that we have generated, and it will actually have created the file in your .gnu-pg directory. So the important thing for you to know is there's your key strength, and that is your key number. That's your key information. Then what you need to do is, now that you've generated your GPG key, you need to export it as ASCII. You can do GPG export -A, that puts it out as ASCII, the user's key you're going to export, and then pipe it out or redirect it out to my public key. And that's just a GPG key. You guys are probably at least somewhat familiar with it, and hopefully you use it yourself for signing emails and things like that. So that's what that looks like. What you need to do then is tell RPM build about your key. And the way that you do that is you write that to your RPM macros file, the .rpm macros file. So you can do GPG list keys. There's your public key. Remember, that's the key. That's the one that you want. You write that information. You say, we're going to use a signature, and it's going to be GPG, and you write that to your macros file, your RPM macros file. You echo the GPG name and that string right there to your RPM macros file, so you've added those two lines to the bottom. Now, whenever you build or sign an RPM, it will be signed with your GPG key. The next thing you're going to do is grab whatever your source is. In my case, when I wrote this, 2217 was the latest and greatest. So you grab it and you put it into the RPM build sources directory under your home directory. Real simple, just wget it or whatever makes sense to you. Now, you remember we need to add in a path statement and a man path statement. You should not put that into etc profile. Create a small shell script that's going to be dumped into etc profile.d. The etc profile.d directory is where you put in individual shell scripts for individual packages. So you're going to create the shell script, you're going to put it in the sources directory as well, and it's going to wind up in the profile.d directory on the systems. And it can be really simple. I just created a little apache.sh that sets my path and my man path statement. That's all I need, but it's in its own discrete file. Now, because we know that there's a bug in using make dester, we need to patch. We need to create a patch of that makefile.in file. Copy the original file to something with an extension that makes sense to you. .orig makes sense to me, so I copied it over. You can use the gendiff utility to create your diff file. And the way that looks is you create you unzip it, or unpack, I should say, your tarball. You copy makefile.in to makefile.in.orig, make the changes that you found on the most important IT tool, Google, and then run gendiff. And it'll kick out a patch file that looks like this. If I cat that file, it'll tell you exactly which file it was that we made changes to. It'll tell you the lines that it took out, and it'll tell you the lines that you put back in. This is going to make recreating what you've done a lot easier. And remember, too, that the design philosophy of building RPMs is we always use pristine sources. You can patch them all you want, but you got to write down what those patches are. You have to have a log of what those patches are. So I've created my patch file, and I stick that patch file over into my sources directory. So remember, anything that we're going to add into the RPM that's not the original tarball, put it into your sources directory. Okay? Now, go to that directory, go to your sources directory, and we need to create a start-stop script. The RPM dev tool has a utility called RPM dev new init, and you give it a name. RPM dev new init httpd, and it generates a file, httpd.init, and here's what it looks like. Initially, it's relatively blank. There's not very much to it. It just gives you the check config stanzas. It reads in the functions file. What I did was I went in and I edited it, and what's cool is there's actually even comments in it when I generate that new init file that says, if it's not running, you should probably start it by this command. And so I put in that command. And then down below, the kill section, same thing. It says, you should probably use kill proc, the utility. I heard that. So it's very, very simple. The skeleton or the framework of the init script is actually very complete. So it's an incredible tool to help get your application into production. How many folks have ever tried this and like you use an existing init file and you kind of cobble it together and hack it up, and it takes like 84,000 iterations before you get it right? Right? I am not a developer. I should have made this clear at the beginning of the class. I'm a sysadmin. I've been a sysadmin for 20 years. That's what I do. My academic background is not in software development. So the first couple of times I built an RPM, it was agonizing. So use this. It's going to build it out for you and even give you hints as to what you should populate the init script with. So now that we've got the init script and it's in the sources directory, pop over to the specs directory. And again, RPM dev comes to the rescue. You're going to give it the command RPM dev new spec httpd, and it's going to create a spec file. The spec file is the framework from which the RPM gets built. This is kind of where the magic happens from building an RPM. So the spec file that gets generated, again, initially, pretty much empty. You can see it doesn't have version information, doesn't have release, it doesn't have any of that information. It just has a very basic build macro, which is, honestly, actually, let me back up just a little bit. Down here, the setup -q just untars it, right? Tars the xvf, whatever the file is. Down here, it does a configure make install just for you. And then it deletes the build root, just in case there was old cruft in there. It make installs to that build root. Once you're done, it'll delete that, and then there are no files defined, and the change log is empty. So that's not going to be a very effective spec file. You do need to go in and make some changes to it. When you go in and make the changes to the spec file, it'll probably wind up looking something like this. Remember, it said what the name was. We've put in the version and the release. So I'm building version 2217-1, and it'll actually even put in the distribution, EL6. I give it a summary, and I say it's my HTTPD for Acme Widget Corporation. I'll say what group it's in, put what license it is. It's the Apache Software License version 2. Where I got it, what the tarball is, and notice that I specify, I've got these other two source files besides just the tarball. I've got that apache.sh file to set the path and the man path, and I've got my init file. I also can call out, I have a patch here. Patch 0 is my make destdir patch. I can put down what tools are required to build it, and I can also put what packages will be drawn in when I yum install this. So I'm defining what my dependencies are. How did I find those out? I read the installation guide, and it's all called out in there. Okay? So it's fairly straightforward. And if you get into a bind, if you're building like a custom version of Apache and you know there's already one out there, but maybe it's older, go look at that spec file. You can cheat and go look at it. It'll tell you what you need. So I put my description. Notice that under prep, I didn't just do setup, I also did patch P1. That tells me to apply one directory depth or apply that patch that's available for me. And I did something a little bit different here. The default configure macro assumes that you're just doing configure make install. But remember, we're doing configure prefix equals opt Apache, so I edited that. I changed that, so this says prefix equals opt Apache. I left the make alone. And a couple of things that I did differently was before we actually generate the RPM, I made the profile.d, the init.d directories, and then I used the install command to install them with the mode 755, which means they're executable, into the source from the source directory over into the build directory. I did the same thing with the init file over into the init.d directory. And then I populated the bottom section, which is all of the files that are going to be installed on the system. Now that section's pretty big. That section's pretty big. We'll come back to that in a second. And down at the bottom, I put the changelog. There is a specific format for the changelog. It is the day, the month, the date, and the year, who did it, and then you got to put some string in there. And I put first attempt. Now, how did I get that big old honking list of files? I kind of cheated. I did it myself. I did configure prefix equals blah, 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 and I did make dester var temp install. Then I went over to var temp install once it was done doing all of this, and I ran a find command. I said find all of the files of type F, strip off the preceding dot, and just redirect it into the bottom of that spec file. And then I copied and pasted. I moved it into the files section. It's pretty easy, actually, just a little bit of find foo. Now, when you build an RPM, there are multiple phases for RPM build, okay? If I do RPM build -- help, I can actually test each section. I can do RPM BP to just go through the prep section, go through the build section with BC, BI goes through build install, BL goes to verify this, the files section, BA says build the source RPM and the binary RPM, and BB is build the binary only package. Or you can do BS to build the source only package, et cetera, et cetera, et cetera. So let's look at what that looks like, right? I look into my RPM build directory, and I notice all I've got is I've got my source tarball that's pristine, because remember, we always use pristine tarballs. I got my init script, my patch, and my shell script, and then I have that spec file that I just created. First, we're going to do the RPM build -BP. Let's just go through the prep section and make sure nothing blows up, right? So I do RPM build -BP, it gets done, exit 0. Okay, cool. I know that I've got all my sources and stuff in the right location. I'm good there. And if I go and I look in that directory, I see that it unpacked my stuff into the build directory as I expected. So we're good there. We know that at least our unpacking section of the RPM is good. Now, I'm going to do -BC. So it's actually going to go through and extract, and we're going to go to the next section. And sure enough, it goes through. It actually does the compile, gets done, and I don't see any errors. I got an exit 0. Okay, cool. I know that my compile works. We're in good shape there. The patch got applied appropriately. We're in good shape. The directory structure hadn't changed that much. It's still got all my stuff down here in the build section. So the next thing is, let's go through the install section. Let's see what happens when we go through the mock install to that temporary build route where we're building it, or the installation route, I'm sorry. So I run through it, I go through, it does the compile, it gets down to the bottom, and it says, checking for unpackaged. Okay, it exited without an error message. So man, I'm feeling pretty good about myself right now. I think I've got my RPM that's pretty close to being built. Again, now you'll see a new directory. I've got that build root directory, because remember how RPM works, right? You do the compilation, and it actually writes to a mock location that mirrors what your file system looks like. So now that I've done the install section, I've got that build root, and that's fine. That's okay. This is also a good place to go back and verify that your files section is correct. You can look in that RPM build root and just check to make sure that your files match up. But we're good. We know that they do because we tested that section so far. So finally, hey man, let's build a binary RPM. Let's get ready to install this bad boy. So I do RPM build -BB against the spec file. It runs through, it unzips, it gets done. You see where it creates my RPM, my HTTPD with the label that we did, the -1 EL6. It also built a debug info RPM in case you need to run debugging against your binary. And so we're good. Exit 0. We always want to see exit 0. If we see exit 0, we know that things are generally in good shape. And again, we've got, this is kind of interesting, it built that build route, but remember as part of the cleanup, when you get done, you saw that section where it did the rm-rf, the build route. So it'll build it, it'll populate it, it'll compile it, and then it'll nuke it. So just to keep it clean. Now, we know that the binary RPM built okay, so we're in good shape there. Let's do BA. So we build the binary RPM and the source RPM. So I run RPM build -BA against the spec file. We go through and we see that it built the source RPM there. It built the binary, it built the debug info, and we're good, man. It exited 0, so far things are looking really good. And again, that's just what the directory structure looks like. A note about debug info RPMs. I don't recommend you turn it off except in one use case, which we'll talk about in the second half, to disable stripping binaries to make the debugs, the debug RPM. You can add a line that says define debug package is nil, so it won't create the debug package. Note that you will probably have to change your files section if you're going to do that, because the stuff that was stripped out and put in a separate RPM is now going to appear in the main RPM. Does that make sense? Okay. So if you're going to do that, you just add the line, define debug package nil, and this time when you run it, you'll notice it makes a source RPM and the binary RPM. There's no debug RPM. Don't do this unless you have a good reason to. You know, the debug information, if you're never going to use it, fine, throw it away, but don't put all the debug symbols and stuff into your primary binary. That, you know, it's kind of sloppy. Finally, what we're going to do is we're going to sign that bad boy. We are going to run RPM -- resign against that RPM, enter the passphrase, looks like it's in good shape. You can import the GPG key into the RPM database and install and test. And the way that you do that is RPM, first off, we want to check it. RPM's check sig, and you'll notice that when I do this before I imported the GPG signature, it comes back and it's like, nope, failed. So now I do RPM import, -- import, that Acme widget GPG key. If you were here in my first session about RHN satellite, you should put that key on your satellite server on maybe the pub directory. You can run RPM -- import against a URL as well. You could do http://yoursatellite/pub/myfancy key. And it'll import it from across the wire. So where before we got not okay, now when I run RPM check sig, it comes back and it says, yep, we're good. I've got the signature. So I recognize that this is a signed package. That RPM key needs to be imported on every machine upon which you are going to be installing this package. Do it through your satellite server. If you want to know how to do that, download the slides from my previous session. They're up, and you can learn how to do that. So now it's time to check it. I'm going to do a local install of it. This could be done through the satellite server or locally. So I do a yum local install against it. It sucks it in, checks all my repos, dependencies resolved, brings it in, boom, it's installed. Hey, it installed. Man, we're doing pretty well so far. We built this RPM, ready to go, and we go to restart or start the service. Damn. So you go and you look, and it says, could not open the error log under opt-apache logs. So we're going to go back to the spec file. It's a real simple fix, and this is kind of the iterative way that you build packages. This is the reality. You'll build it, and it'll go great, and you're like, ooh, I'm so good at this, and you know, boom, smoke comes out of the back of the server. People are pointing and laughing. It's terrible. So back to the spec file. All we need to do is we need to add that directory to the spec file so that it gets created by the RPM and owned by the right user. And so it's simple. We go in. You have to rev your release number. This is a common and terrible mistake. You're like, oh, it's just one line. So now what happens is you've got a version of the RPM that's -1 that's broken, and then you've got another one that's -1 that works. Don't do that. Make your life easier by just upping the release number, okay? Go down to the section down here and go, oh yeah, we're going to make a directory called opt-apache logs in the RPM build root. And don't forget, go down to the bottom and put down why you did what you did. This is so if you're the one who wins the lottery and you're done, you're on a beach drinking a little umbrella drink, the poor sap who comes in behind you has an idea of what you did, okay? So you make a change. You go through and you do the recompile. Brum, 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 it went. You go through and you do the yum install. Actually, it's an update, so it does the installation. And service httpd init start. Boom! It's up and running. And that's how you package an internally developed RPM. It's fairly straightforward. Now, I've made it look really easy because I've done this enough times and shot myself in the foot enough times. There are always going to be those weird RPMs that like they use some crazy M4 to build the RPMs. Those are going to be more challenging. But this basic framework, this is going to be the same across anything for which you have source code for. The main thing is just to remember each one of the sections of the spec file. Use the tools. Use RPM dev. I am lazy. Anyone who's been at any of my other presentations knows that's like a common thread. I am lazy. I don't want to edit that spec file by hand. Use the tools to generate the framework. Use the tools to generate the framework of the init script. And when you go through all of that, you should be in good shape. And here's something that's kind of cool. Because in the files section, I don't know if I showed you that. Let me pop back real quick. Because in the files section, well, I didn't, it's on there, but I forgot to point it out. There's a section in this part that's up above a little bit that I put a lot of sections that did %config or %doc. Your documentation files, call them out as documentation files, and if you call out your config files as config files, when you go to uninstall the RPM, what's kind of cool is if you do anything that you've made any changes, it'll say, I'm going to save that for you. Because you may want to keep that config. Even though you've uninstalled the RPM, maybe you're going to install a newer version. So it'll save it for you. Ditto for your vhosts file or whatever. Anything that you've changed, RPM is smart enough to go, he or she may want to keep that, so I'm going to leave it here as a .rpm save file. Okay? And so when you do that, if you look under the opt directory, the only thing you'll find that's left is my log files, because we never delete log files, and my config files saved as RPM save. So, does that make sense? It ain't rocket science. First time I built an RPM scared the heck out of me. I don't mind telling you, because I am not a developer. And I was like, oh my gosh, I got to compile code. This is going to be awful. These tools make it to where you got frameworks in place, and it becomes just a matter of fine-tuning. It's not like, oh my gosh, I got to develop this thing from scratch. So, well, that's all well and good, right? Okay, Thomas, I've built this RPM for which I have source, but I got this application that the vendor sent me, and it's on a CD or it's on a tarball, and I got to run some crazy installer, utility, and I don't really necessarily have visibility into what all it does. How do I package that? Because you'll hear me say you should never ever deploy non-packaged software on a package-based system. I don't care if it's Debian Debs or Red Hat RPMs. Doing tarballs just is awful. So how do I do that? How do I make that happen? It does make it hard to centralize version control, it makes it hard to centralize integrity checking, and it makes it hard to centralize deployment. And no, for I in host 1, host 2, host 3, do SCP, blah, 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 is not an enterprise software deployment system. You may use it in your enterprise, it's not an enterprise deployment system. So, let's say that I have this just silly little hello world type of RPM that I've got. But I've got an RPM from an application which has been installed by an installer, and I don't have any view into what the installer does. Here's what I do, and there's a number of ways you can do this. You can use aid, which is a file system checking utility. It's kind of based on Tripwire. You can use aid, or I'm lazy. What I'll do is, right before I do the installation, I'll run the mlocate script that updates the database of all the files on the file system. I'll run mlocate, and then I'll dump that to a text file. I'll do locate asterisk and then pipe it out to a text file. Then I install my application, and I run mlocate again. And I dump it to a text file. And then I diff the difference, or I diff the two text files. Now I know what's on the file system that wasn't there before. I got to weed through a little bit of noise, and I'll show you an example of that. And then I use find to find anything on the file system that's newer, that's been modified since I took that first one. And here's what that looks like. I run mlocate.cron, I locate star, and then pipe it out to before.txt. I go into my temporary directory or wherever my installer is. I run my installer. It's a shell script, but let's pretend it was a binary installer. I run my shell script, I pop out of there, I run mlocate.cron again, and I dump that out to a text file. Well, I go to diff the two of them, and it shows me, ooh, I've got a foo.conf file, I've got an ld.so.conf file, and I've got a bunch of stuff over here. I've got a bunch of libraries and a bunch of binaries. Oh yeah, that's just the locate database. I can ignore those. That's a known issue, right? So I now know everything that was done to my system, right? Yeah, not necessarily. Yeah, not necessarily. So then what I do is I find from the root anything that's newer than that before.txt file. Show me everything that's been touched since then. And I cut a bunch of stuff out, like I don't care about what's in sys or proc or even in temp. And so it tells me a couple of things that I expected, right? The stuff that's under var run, I don't care about that. Okay, we knew about that. Ooh, those scumbags. We find that, we find the foo.conf, and we knew about all these. So you know what? I think I know what all I've got on my system now. I'm pretty sure that I've got a pretty good handle on all the changes my installer made. Something's always going to come back and bite you, I promise. You're going to run across that one crazy thing that's going to be dated like 4 years ago. But for the most part, this is a pretty good way of doing it. So I see that I got the foo.conf, I got the ld.so.conf.d. We know that Etsy profile was changed. Now we got to go dig through it. And we know that all the stuff that's under opt my app bin, okay? We also know about the stuff that's in the lib directory, and we know about the stuff that's in the sbin directory. So now we got to go figure out what the heck these guys did to my Etsy profile file. We go and we take a look through it, and sure enough, you should be so lucky that they actually comment their changes and tell you what they did. But I find that, oh, okay, I see what they did. They just said if the ID is, if the user is the root user, then the path is going to include sbin. That's all that is, okay? So now I know what they've done. Where should this have gone? Profile.d under the Etsy directory. Very good, very good. All right, cool. So the only one of these which may need to change from system to system is the foo.conf file. We go take a peek at that and we go, ooh, you know what? It's, when I installed it, it defined what this host is, but it also talks about what my foo collector is, whatever foo is, my foo application. I use foo and bar a lot. Now remember, if you guys were here for my first section, RHN Satellite has the ability to define custom installations or custom config files on a per host basis. Again, go download my presentation from the first hour if you want to learn how to do that. So, config file macros in RHN, good stuff. The way that I'm going to package this now is I'm going to create a directory. Call it whatever the app is, the version, and the release number. So my app 1.0. Copy everything into that directory. You can just dump it all into the directory. I personally prefer to do it in the same hierarchy as it was installed on the file system. Not because it makes any difference, but just because it's easier for me to remember which one is which, right? So what I also did in this next screen, I've been told it's a little bit confusing, but there is a method to the madness. I use tar pipe tar instead of just copy because that will keep all of the ownership and attributes and things like that. If you do cp-a, it does pretty much the same thing. Whatever, whatever you like to do. This directory is going to be the root of the RPM that you're going to build. So I go in and I make my directory. I tar pipe tar so that all the ownership and permissions and extended attributes and all that stuff get kept. I copy all that stuff in, and so now if I look in my foo directory, I've got the entire layout just like it is on my file system, as if this were the root of my file system, okay? This is easy for me to read. Not only am I lazy, I'm not the sharpest tool in the shed. This makes it easier for me to keep track of. So if you don't, since we don't want to modify the system-provided Etsy profile, again, we're going to create that little script that's going to get popped over into Etsy profile.d. And that's real simple. We just take what they did in our profile file, put it into a little shell script, and remember that we're going to put that into our source directory, or the directory that we're building that's going to be the source for our RPM. So now we've done it. We've got all of our library stuff. We've got our profile stuff. We've got the binaries, the libraries, the system binaries. So life is good. Create a tarball or a tar-gz or a bz2 or whatever floats your boat from that directory, but use this syntax. Make sure that you use the syntax that has name, version, and build number with whatever the extension is. So I used bzip2, so tar jcvf against that directory, and it spits out foo-1.0.tar.bz2. That is now my source, even though it's not really source code, that's my source for my RPM. Put it someplace where a non-root user can get it, remember? Non-root to build RPMs. Don't build RPMs as root. So I pop it over into the temp directory and I change the permission so that my RPM building account can get to it. Now that I've done that, again, make sure you got the RPM dev tools, all that stuff. Create your RPM tree. We kind of already went through this, so I'm not going to spend a lot of time on it. RPM dev setup tree. Copy the tarball into your sources directory. Create the specs file. And here's what you need to do on this. When you create the spec file, we want to do the setup, which is extracting. We want to do the prep, which is looking for any patches or anything like that. Do we want to do configure, make, or make install on this? No, because it's not actually source code, right? These are binaries from some third-party vendor. So we also don't want to run the GNU strip utility against things that were maybe compiled by an Intel compiler or something like that. So when I talked earlier about you don't want to turn off building debug packages, except in some cases, this would be one of them. So it's going to look like what you saw already: foo 1.0, build 1, all this information. Make sure you define debug package nil. We've got the prep and the setup, but notice that I commented out the install section because I'm going to do it manually, and there is no make section in there. We don't want to compile it. So what I do is, instead of doing the install macro, which is defined under user share RPM, I'm going to do this all kind of manually. And the way that I do that is, I'm going to, in my build root, make that directory structure that we know we need. I'm going to install using the install utility so that I can set the permissions, all of those, the foo, the bar, the baz, all of the libraries, all that kind of good stuff. I'm going to put the config file in there, and I'm going to put the conf file in there. So I'm going to use the install utility to set permissions on it, stick all that stuff in there, and now I go down to the bottom, I make sure that I log all of my files. I still build my files section, which should be easy to do because we've already got that directory that we built all the, that we built the pseudo file system in. I'm going to grab all of that stuff, put it in there, put my changelog into that RPM spec file, and we're going to give it a whirl. Yes, sir? Did I? Ooh, you got me. I did not. Busted. Yeah, I forgot to put that in as a conf file. My bad. My bad. Wow. You're the first person in like 2 years who's caught that. Damn you! Thank you. I will fix that for the next presentation. So I do RPM build -BA because I want to build the binary and the source RPM. And it jumps through all the hoops. It spits out my source RPM. It spits out my binary RPM. Exit 0. That's a good thing. We like that. And I look and I see that I've got all my stuff in my build directory for my source RPM, including now I've got those 2 RPMs, the source RPM and whatever. Again, make sure you sign it. RPM -- resign using the key that you defined in your RPM macros file. And I did RPM, but I could have done yum, either one. I fire that bad boy up. I log into localhost. My foo command works. My bar command works. Ooh, wait, I run the baz command. Why didn't that work? Because I'm not root. That's how that foo.sh works, right? When it processes, it's going to run whenever I log in. And so now I do echo $path, and sure enough, there's opt_my_app_bin. So we're in good shape there. If I SSH in as root and I run baz, sure enough, I've got user, where'd it go? opt_my_app_bin and opt_my_app_sbin right there. So that's what that little shell script does. So now I've gotten a package that I can deploy through RHN satellite, which gives me MD5 sums on every single file inside of that package, which gives me version control information, gives me the ability to upgrade, downgrade, install, remove, add to a package manifest. It makes my life easier as a sysadmin. I don't have that cowboy who's out there going, oh, I know better how to do this than that idiot did. I'm going to run a different compiler flag because I'm a Gentoo dude and I'm going to optimize the snot out of it. So hopefully the end result of today's presentation is building RPMs, you know now, it ain't rocket science. It's not the easiest thing in the world. It'll take you a couple of times. There will be trial and there will certainly be error. But I hope that this has taken some of the mystery out of the process, and I hope this has given you a good idea on how to do binaries. As I said, my contact information is up there. On behalf of Red Hat, thank you very much for coming. We do appreciate you being here, and for me personally, thank you for letting me present.